All right. I'm just double checking right and see that it's going to work for sure. And I think it is. Awesome. I'm going to get started. Oh, there I am. So I have questions on the Google Word doc that we're sharing, and so that's great. I'm going to start from the top of there. What does r squared mean on the graph? I'm putting my time. Where's my time? Well, it's 8:04. So got to be like 4 minutes in. What does r squared mean on the graph? R squared is that value that you'd see right below your equation of the line, and r squared will be like 0.99. That was mostly what a lot of people got for the graph for the water lab, or it could be something terrible like 0.72. And the r squared value is basically telling you how good do the points on the line follow the line. So how good is the line of best fit? If the line of best fit is awesome, like it goes through all of the data points perfectly and right through the center, then you're going to have an r squared value of 1 or 0.99 usually. That's kind of like saying like it's 100% or 99%. It's awesome line of best fit, and that's kind of what you're going for. If you have an r squared value of 0.72, it's kind of like it's a 75% correlation. All the data points are pretty darn close to it, and things are looking really good. If you have a r squared value of like 0.3, that just means that the line does not go through hardly any points. The points are like randomly everywhere, and the line doesn't have any line of best fit really. So that's what r squared tells you. How great is the line of best fit? Okay, I got my other computer here. That's how I'm seeing my other questions. Could you explain the difference between accuracy and precision? Okay. All right, so if I can get a screen going here. Cool. Okay. I think this is working. I need to find paint. Sorry, I'm trying to find my paint program. I'd like some place to write. I think you're seeing what I'm seeing. This is great television here. Microsoft. Hey, Tim. Oh, there it is. Okay. Okay, there's a difference between accuracy and precision. 806, really. When you're looking at accuracy, that's when you're trying to get the exact number that you're supposed to get. So if we take something like we're supposed to get 26 or something like that. This way. An accurate measurement would be something like 25.75. I mean, you're not far off of that. So that means you're pretty accurate. You're close to what you should have got. If you should have gotten 26, your theoretical value, and you actually got 25, that's not too bad. So accuracy is you got what you should have gotten. Precision is a little bit different. Precision is how close are you, how many sig figs can you have is the most precise way, I guess, to say it. Precision is something that has a lot of sig figs. So this number of 25.75 has a lot of sig figs. It happens to have 2 decimal places, even more importantly. And so when you're precise, you can be really certain of what you're reporting. Like let's say you had a big stadium and you said there's like 24,000 people, about 24,000 people in the room. Well, that's not very precise. I mean, 24,000 is a big number. It could be 24,900 or it could be 24,001. And that's a huge range of over 1,000. So If you have something like you said, the stadium was filled with 24,362 people, well, that's really precise, you know, down to the person. That's a lot of sig figs. So the precision is about how certain you are, and sig figs tell us how certain we are. Hey, Tim, are you out there? Sorry, I'm trying to get my husband to help me with this computer thing. I'll just keep trucking along. Can you please go over the conversion questions from the review game? Yes. I want to see how, because clearly my writing on the screen is terrible, so I want to see if I can write on the screen differently. Okay, let's just go with this. Okay, we'll go with that. Conversion question from the review game. Let me get that one out. I'm guessing that they're talking about the kernels popcorn, because that's one that we did in the review game. So let me go find that question actually. Hey Tim, does the computer not use this like stylus to write? Like I can write later, but this thing doesn't like register it. I took this from my computer. Or do you not really know?
Well, you're using all three, huh? No, I don't know what the stylus is like too.
You can't register it, maybe.
It might be too pointed.
Okay. Well, this one seems to be working, so yeah, you might be right. It's too pointed. Okay, that's fine. I'm going to answer my popcorn question. Okay.
Do you need to plug in?
I'm sorry if my writing is pretty terrible. My school computer isn't working, which would have been the best thing for this, so I'm using my home one. If you go to the review game, you can see it's slide number 7. Slide number 7 is the actual question. It says the average kernel of popcorn is 0.125 grams. They have 1 pound. Maybe we can just get the question out here. So that you can see it on the screen. So it's slide number 7. Okay. So here's the question. Average kernel of popcorn is 0.125 grams. If 1 pound equals 16 ounces and 1 ounce is 28.3 grams, how many kernels of popcorn are in 0.5 pounds of popcorn? I'm going to kind of make this smaller, so you might have to zoom in for yours, but I think that way I can write on it, which would be cool. So let's do it this way. Is there a right feature? Silly Google. Well, we'll have to double screen this then. Okay, we'll just go like this. So the question is how many kernels? So I'm going to go question mark kernels. Once again, I apologize that this is going to be terrible handwriting. The question says how many kernels of popcorn are there in? So that's the number I put on the other side, 0.5 pounds of popcorn. So multiply that by a conversion factor. And I don't really know where I'm going to go yet, but I do know that I need to get out of pounds. So I'm going to put that on the bottom. That way they'll cancel. Now, if I go back to my screen up here, up on the top, I'm going to kind of figure out where is pounds. Well, I can see pounds is right here, so I might as well go there. It says 1 pound is 16 ounces. So I'm going to put ounces on top. 16 ounces is 1 pound. I still don't actually really know where I'm going, but that's all I know about pounds, so I might as well go there. It gets me closer. Then I'm going to multiply by another conversion factor, in which I'll put ounces on the bottom. That way they'll cancel. And if I look at the top, Trying to find something about ounces. Well, this is the only thing that talks about ounces. So I'm going to go to there. It says that 1 ounce, so 1 on the bottom, is equal to 28.3 grams. All right. Well, I still don't exactly know where I'm going, but grams is at least not pounds, and that's what I would get out of. So I'm just going to multiply by another fraction. I'm going to have to head down here towards the bottom. And on the bottom, I need to get out of grams. Grams on bottom, grams on top. That's why they'll cancel. And now if I look for another grams number, that's this number right here, 0.125. 0.125. And I think what made this one so tricky is that the way it said the average kernel of popcorn. Had I changed the words to say 1 kernel of popcorn, 1 average kernel, and put that number 1 in there, it wouldn't have been so tricky for you. But what it's really saying is that 1 kernel of popcorn is 0.125 grams. Not every kernel of popcorn is 0.125, but the average is. So this is the best conversion factor that we have. So really you might be thinking like, this is a sig fig, and yeah, it kind of is a sig fig in there. It's kind of a wishy-washy thing, like, is it sig fig or is it not? But when we sig fig things, we really want to take a look at this top one. This first number here is most likely going to be your actual sig fig thing to look at. So I bust out my calculator here, and I'm just multiplying across. I'm dividing on the bottom. Oop, I did let's try this again. Okay, my calculator spit out 1811.2. So considering sig figs again, I'm going to take this first number. It has 3 sig figs. These zeros aren't just placeholders, they're sig figs there. They're there for a reason. So this should have 3 sig figs, which means I need the 1, the 8, and the 1, and then a 0 afterwards to be a placeholder. I have 1,810, and for units, kernels. And that's what I got. All right, let's take a look at what our next question is. Okay, the question I have is about interpolate and extrapolate from a graph. So this is starting 15. So I'm going to find a graph here. There was graphs I was going to use for the review game. I don't think I have those available right now. So we're just going to Google a graph. Here we go. Let's find something like on global warming. Those are usually really good graphs. They're kind of like intense ones. I like those ones. Ooh, this one's fun. Okay, let's do this one. Here we go. Okay, so this is temperature change relative to its normal temperature. So average temperature would be the 0, and it's saying that in the year, like 0.25, whoop, this year right here, 1938, it seems to be 0.25 higher than its normal temperature. So interpolate is what I just did here, to look at 1938 and be like, okay, at 1938 it is 0.25 degrees warmer on average than it would be at any other time. That's the idea of interpolating, just using the graph data that's presented here. I don't have to guess what it is, I can look it up. Extrapolate is to kind of assume. So in 2010 here we can see we'll go by the blue line, it is about 0.75, so almost a degree higher. So I would extrapolate to say it will be on average a degree higher than it should be on average in 2030. That's me extrapolating. I'm saying in 2030, it's going to be a degree higher. Do I know for sure? No. What I could do is get the equation of the line and do some math like you're doing in the hard water, soft water lab, and kind of have a better prediction. But right now I'm just extrapolating straight from the graph, basically making a guess, like where do I think this line is when it's off the graph grid? And that would be what extrapolating is. Let me check that my volume is working. Yep, okay. That is that. How do we use conversion factor to solve dimensional analysis problems? Okay, to this person I'm going to say, see question above. at 808. Okay. I'm on to my next question. How to calculate error. And there are ones where one, okay, these are two questions. How to calculate error. Well, the good news on calculating error is I'm going to give you the error equation. So you don't have to like question what that is. Just get a new screen here. Okay, so on the top of the test, I give you the equations for change in temperature, whether you're going Kelvin to Celsius or Celsius to Fahrenheit, and I also give you the percent error equation. So percent error is absolute value bar. It could be on top or overall, it doesn't really matter. It's a theoretical on the bottom, and a theoretical minus experimental. You might see it the opposite, like experimental minus theoretical. It's just the difference of the two on top. Since it's absolute value bars, it really doesn't matter what order it comes in. Then we're going to times it by 100. So this is the basic equation. So what would happen is, let's say you have a density, and you found it in the lab to be 11.2 grams per milliliter. But it was, I don't know, something, a totally different substance. It was a piece of wood and it actually had a density, they might call it actual. Its actual density was 12.1 grams per milliliter. Okay, well, this is your experimental one. This is what you got in the lab. So that is the number. This 11.2 is what goes in the experimental spot. Your 12.1 is what goes in the theoretical spot. So if I happen to do that math, I get 12.1 minus 11.2 divided by 12.1. And I'll do absolute value bars, or whatever answer I get, I just have to get it to be positive value. So I'll do some on my calculator. 12.1 minus 11.2. My calculator spit out 0.9 for that top, divided by 12.1. Now my calculator really did spit out though 0.9, but using sig figs, 0.9 is a proper sig fig for here. So when I use my subtraction rules on the top, I can see that they both have point something. They have one decimal place, so my answer should have point something, which it does. So I've got proper sig figs at this stage. So now I'm going to divide it by 12.1, times it by 100, and I get 7.438%. Thinking about sig figs, now I've got, like I said before, this is my proper sig figs, the 0.9. The 0.9 has only one sig fig, so I can only have one sig fig in my answer. So I would say my percent error here is 7%. And that'll be my answer. And it would show accuracy. So my accuracy would be considered as like 7%. Okay. Oh, I didn't put my time on that, but it was about 8:20. I'm gonna get to the solve with Troy Grain or something, I don't know. Okay, so this is a textbook problem they want me to do. Okay. So I'm going to do a textbook problem, that one where they talked about the Troy of grain and all that sort of stuff. This person, I don't know if it's a girl or boy actually, I just got an email. Page 62. Okay, sounds good. Number, that's 81. So yeah, it is number 81 on page 62. So if you had trouble with this one, you'll have to bust out your textbook because I'm not going to be able to write it down. I'm just going to kind of do the problem for you. Okay. So the way I did my textbook homework on the answer key that you saw in class today was one way to do it. Assuming you've already looked at that, you might need a different way to do it. I'm going to do it a different way here. So if I look at the question, it says a troy ounce is equal to 480 grains, and 1 grain is equal to 64.8 milligrams. If the price of gold is $560 per troy ounce, what is the cost of 1 gram of gold? So that's where I'm going to focus right now. What is the cost of 1 gram of gold? So my question is, What is a cost? Cost is money. How much money does 1 gram of gold cost? Okay, that's my problem. So I need to get out of grams, so I'll put those on the bottom. That way they'll cancel. And I really don't know exactly where to go. If I look at my conversion factors, I don't have a grams thing, but I do have a milligrams thing. So I'm going to get out of grams and into milligrams. That's my first step. Well, to do that, you got to think of King Henry died by drinking chocolate milk. So my grams is my base unit, and my milligrams is this M over here, milligrams. So it took me 1, 2, 3. That's a 10 to the third difference. The 10 to the third will always go with the right-hand thing, whatever it happens to be, whatever happens to be on the right side. So I have 10 to the third milligrams in 1 gram. First conversion factor done. I'm going to get out of milligrams, so I'll put those on the bottom. So I go back to the textbook, and it told me for milligrams that I can go from milligrams to grains. Frankly, I don't know what grains are. You probably don't either, but I'd say let's go for it. In the book, it says 1 grain is equal to 64.8 milligrams. Okay, sounds good. Multiply by another conversion factor because I want to get out of grains. My whole goal is to get to money. So I'm going to get out of grains. And I think I'm getting closer because now that I know grains, I can get to troy ounce. And once I know troy ounce, I can get towards money. So we're getting there. I'm going to get out of grains and I'm going to get into troy ounce. Once again, I don't really know what those are, but that sounds great. It tells me in the textbook that it uses the term A, which is 1. 1 troy ounce is equal to 480 grains. All right. Keep going. On the bottom, we'll put troy ounce because I want to get out of it. That way they'll cancel. And according to what I've got going on in my conversion factors in the textbook, it tells me that a troy ounce is $60. Okay, even 1 troy ounce. I finally got to money, which is totally what I wanted to get to, is money. So at this point, I just had to bust out my calculator. And that's what I'm doing right now. Okay, my calculator spit out 18.004115. Now, we got to think about this, what we got going on here. This is based on, the units are going to be money. And in money, or dollars is what I'm looking for, this conversion factor right here is infinite sig figs, and infinite sig figs, and infinite sig figs. But money can also be infinite sig figs if you have a counting unit. So really, I've got infinite sig figs there too. This 1 gram, it doesn't say, well, it does say 1 gram, cost of 1 gram of gold. So you can consider it to be 1 sig fig. So with 1 sig fig, I would have to say this has to round up to $20. I think that one's kind of wishy-washy because you could assume that 1 gram would be, infinite sig figs in a way, but because the textbook answer says it's 18 grams. I disagree. $18 per gram. I would go with sig figs, and that's what I would do tomorrow in the test. Look at your front number. This one has 1 sig fig, so 1 sig fig, and my answer would be 20. $20 per gram could be one way to write it. Okay. There you go. I'm going back to my document things. Okay, I am on to the 827 one. This person has read the textbook. The question says, does precision refer to the consistency of data? Yes, it does also talk about that. More important to me, so this is a textbook information. More important to me, precision talks about sig figs, but it also does talk about Precision tells you about the consistency of data. So for those who might not be following along here, like let's say you have a data set where you've got 8.37, 8.38, 8.35. That was like a mass of I don't know, a piece of wood or something like that. And then that was with one balance. These are in grams. And let's say you had another balance, and it has, 8.32, 9.64, and 7.11 grams. Clearly, you can see that these ones happen to be consistently closer to each other. And that's kind of what this person is talking about in the question, consistency. This one is also considered more precise. This balance is clearly not accurate nor precise. It happens to be all across the board. So precision can be about how consistent you are, but usually consistency doesn't happen like the example I gave here. It's more likely that the consistency is going to happen like this sort of situation. Do you see how this has fewer sig figs, or it has a larger decimal places? That's not a good way to say it. It doesn't have any decimal places. It's last sig fig is in the tens place. So we don't even know what the ones place are. So the fact that these aren't directly consistent, or they're not kind of sitting in the same area, kind of makes more sense, because you must be measuring it with something that's less accurate, that happens to be less precise for sure, because they have less sig figs. So consistency in data usually will happen when you have more decimal places or more sig figs. Less consistency in data will usually happen when you have less sig figs. Precision is about sig figs and it's about consistency, but I'm going to expect you to know really about the sig figs thing. That was kind of our topic. If you know the other part, that's great. Okay. The question says, what will the written portion of the test be like? Will it be question answer or short answer? Could you give examples? I can't give you any examples of what's going to be on the short answer. That's kind of what the test is about. You should be able to do anything, a written part, like I might ask you to ask an essay sort of question. I might ask you to do math. I think it's pretty obvious I would do a math question. Will it be short answer? Yes, it'll be all of that. So to that person, I'm sorry that this probably was not the most stellar answer that you were looking for. Thank you. This is bringing my screen back. Oh, hello. Okay. Oh. Okay. We're going to do textbook homework number 83 from page, 63. All right. Okay, so you'll have to bust out your textbook if you want to follow along here. I'm doing page 63, number 83, the blood one. Once again, this is one where I did it differently than I'm going to do it now. What I mean is the textbook homework you saw in class was one way to do it. I'm going to do it a different way here just to make things maybe work for you better. Okay, so if you read the problem, the question says how many milliliters? So that's my question. How many milliliters of oxygen? That's important in this one. It is of oxygen. They talk about of blood and of oxygen. So I put O2. O2 is a shorthand for oxygen. We'll get there. So how many milliliters of oxygen does each gram of hemoglobin have? In 1 gram of hemoglobin. Oh, I guess I'm going to do hemoglobin like that. In 1 gram of hemoglobin. Now, it doesn't say one particular gram. It says each gram. So really, I'm going to remember that this is infinite sig figs because it says each gram as I look at this. Okay, so multiply it by a fraction. I want to get out of grams of specifically hemoglobin. And I'm trying to get myself towards milliliters of oxygen. So if I look at my conversion factors, the only thing giving me about grams of hemoglobin is to go to milliliters of blood. So it says that in 15 grams of hemoglobin, there's 100 mils of blood. Hemoglobin are the red blood cell parts that live in your blood. Okay, they don't live, they're not really alive, they're not, okay. Yes, so grams is canceled. And I want to get out of milliliters of blood, so I'll put that on the bottom. That way they'll cancel. And if I look in your textbook, another thing about milliliters of blood is I can go to actually milliliters of oxygen with my milliliters of blood. So if in the textbook it says if you have 10.0 milliliters of blood, it will carry 2.01 milliliters of oxygen. Milliliters of oxygen is totally what I wanted to get to according to my problem. So at this point, I just got to bust out my calculator. So here we go. I get 1.34. Okay, and so that's my calculator spit out. And so if I look at things here, I already designated that my first number is infinite sig figs. And I can only assume, based on how things are written, that these are also infinite sig figs. So I can't grade you on sig figs. I can just put whatever I want for an answer, and I'm just going to keep 1.34. It seems like a good answer to have. I just need milliliters of oxygen for my units, so I'm good. Okay. Could you go over correlation and causation? All right, correlation and causation. How should I do this differently? I guess a simplistic answer would be if things are correlated, one goes up and the other goes up, or one goes down and the other goes down. Like they kind of do it together, like if you look at a graph. And causation is actually finding out why they would do that. Why would one go up and one go down, and so on and so forth. Well, global warming graphs will be a good one. Ha, perfect. So I think I'm going to be able to get to this graph. I hope it's big enough for you to see. Okay. All right, so correlation. This will be hard to do on that part, but you can see that in this graph, these two lines are correlated. The red line is the CO2 concentration. So as CO2 goes up, the amount of CO2 goes up, it seems to be that the average surface temperature also goes up. They're correlated with each other. One goes up and the other goes up. But that doesn't necessarily mean they cause each other. In this case, though, they do cause each other. We've seen through lots of data that as the amount of C2 on the Earth has increased, C2 kind of creates this trapping of heat. The sun layers go through the clouds. I'm trying to keep this really simple. We're going to talk about it later. It goes through the clouds and it gets trapped in kind of like a greenhouse effect. So then the sunlight and all the heat is trapped underneath the cloud surface, which is mostly made of the CO2 or other types of like methane gas. And so different gases can trap different amounts of heat or radiation, and the radiation sits underneath the greenhouse effect and then increases the temperature of our surface. That part really isn't important, but what I want to say is that we have seen there is scientific data that proves the more CO2 that you have, it will cause the temperature of the Earth to increase. That is a causation. Those two are directly causing. CO2 is causing the other. While if I find another graph that has a positive correlation, like this one. As students spend more time studying, their grades go up. That has nothing to do with these two, but it seems to be that all of these lines are correlating, they're all going up. But it doesn't mean that as you spend more time and your grades go up, it's going to cause surface temperature increase. They aren't causing each other, they're just correlated with each other. Yeah, I hope that helps. Okay. Evidence and claim, what do you mean? That person who said evidence and claim, I'm not sure what you want me to talk about there. Oh, they might be writing more. Oh, I can do that. Okay. Cool. Oh, there's more questions on there. Okay. So what's the difference between evidence and claim? A claim is stating something. Like, let's think about the hard soft water lab. That's a great example. So a claim in the hard soft water lab would be, it's me again. So a claim in the hard soft water lab would be, Mrs. Staub's water was unknown A, which it was. So my water was unknown A. That's my claim. The evidence to support that would be it produced less bubbles. It produced less bubbles, and that correlated with, and that was caused by or correlates with a higher concentration of magnesium. So that would be my evidence. My evidence is it has less bubbles, or my evidence is it has more magnesium. And my claim is Mrs. Staub's water is hard water. Those are the differences. Okay. I am on. The question is, why is 1 gram of hemoglobin infinite, but 1 gram of gold isn't? Okay, if to this person, it's the way they wrote the question in the textbook. So you have to go back and actually look at the textbook question. It says in the textbook question 1 gram, like it uses the number 1, so that suggests 1 sig fig to me. But when you look at the textbook question, it says each gram. It doesn't have like a number, it just says the word each, which I'm assuming to be 1 gram. I think that's a very safe assumption. So the word each suggests there's infinite sig figs, but the number 1 suggests there's 1 sig fig. So you have to go back to the question and actually look at the words for that. What is Sullivan? Question 83. How did you know those numbers were infinite? Okay. Good questions here. 840. This question is about, I'll read it aloud to you. While solving 83, how did you know those numbers were infinite sig figs? Wouldn't 10.0 be 3 sig figs and 15 be 2 sig figs? Yes. So 10.0 is 3 sig figs and 15 is 2 sig figs. But when it's written as a conversion factor inside a question, you can assume, or it'd be difficult not to assume, that there's infinite sig figs. It's like saying there are 12 inches in a foot. Well, 12 is 2 sig figs. So is there really 2 sig figs, or are you really certain that there's 12 inches in a foot? Is it exactly 12 inches in a foot? So I think in these problems, you could say that 10 mils of red can carry 2.01 mils of oxygen. That could actually, you could look at the sig figs, or you consider its conversion factor and say that's infinite sig figs. I wouldn't know how they actually measured it, if it's like 100% certain or not. So that would make it very difficult to do sig figs on, I guess. So that's kind of a crappy answer, I feel like. They don't give us enough data on how they got these numbers, so I can only assume that since they're conversion factors, they might be infinite. But I can completely see how you would think it was 3 and 2. Kind of up in the air. There you go. It will not be wishy-washy in the test. I have 3 minutes left. All right, I'm closing shop. Put away my textbook, my calculator. I'm good.
All right.
Have a lovely night. Get some sleep. I know you never do, but try it tonight.